This video provides an overview of the foundational concepts that will be tested in the Chemical and Physical Foundations of Biological Systems section on the MCAT. The disciplines that are tested in this section are first semester biochemistry, 25%. When I give percentages, it's within 5%. So 25% means between 20 and 30% of the questions on this section will be related to first semester biochemistry. 5%, so 0 to 10% will be intro biology, gen chem 25 to 35%, and organic chemistry 10 to 20%. Introductory physics will be about 20 to 30% of the section of the MCAT. There are two foundational concepts that are covered in this section. Foundational concept number 4 is about 40% of the section, so between 35 and 45%. And it states complex living organisms transport materials, sense environment, process signals, respond to changes using processes understood in terms of physical principles. That's a really long sentence, and there's a lot of words that in and of themselves have different definitions. So for me to understand this concept when I'm structuring how to schedule my review for the MCAT, I want to break this up into smaller pieces. So each concept that I see, one is complex living organisms, and those complex organisms transport materials, they sense their environment, they process signals, they respond to changes, and all of those things are happening using processes that are understood in terms of physical principles. So now breaking apart which each of those things actually means complex organisms transport materials, remembering that for this section, I'm thinking about it how it's relating to physical principles. So when I'm thinking about transporting materials, I'm thinking about how blood is flowing within the human body. I'm also thinking about how blood pressure is going to impact blood flow, as well as how fluid flow. So thinking about fluids and other concepts that might be related to fluids, all of those may be related to how transporting materials occurs within complex living organisms. Are there any others that you can think about? This is just an overview. So with each section, each concept that I overview, there are other things that I may not be listing that are also going to be tested on the MCAT. The organisms also sense their environment. Again, thinking about physical principles. So if I'm thinking about sensing things, first thing I think about is the nervous system. So I'm thinking about nervous signal transmission as well as electricity and anything else that you might be thinking of when it comes to physical principles that allow organisms to sense their environment. So processing signals, again, I'm thinking about physical principles. So the nervous system, brain, how does it actually functioning? So aside from just sensing things, it's also processing things. So again, thinking about electricity, but also now thinking a little bit about mechanics. If we're thinking about how the brain is functioning, some of the velocity, the speed at which signals are transmitted comes into play when thinking about function of the brain. Any other things that you can think about? And these things are also responding to the changes. So if I'm thinking about physical principles again, if I'm thinking about responding, I'm thinking about some kind of movement. So if we're thinking about touching something hot, your response to touching something hot is to move the part of your body that was touching that thing that was hot away from the source that was hot. And so again, we're going to think about mechanics. We have to think about muscles moving and how that's going to make something move, how quickly we need the movement to occur, as well as homeostasis. So if we're maintaining homeostasis, you have to respond to different changes that occur. And so how is homeostasis going to be understood in physical principles? Also thinking chemical equilibrium, that plays into homeostasis. What are shifts in chemical equilibrium? What does that do within the body if we're talking about a complex living organism overall? Solute concentration also goes into how chemical reactions occur that might create shifts in chemical equilibrium. And so all of these things become interconnected even as I'm separating them for concepts. But this is how the MCAT teaches you. This is how the MCAT tests your ability to integrate concepts as well. Are there any others you can think about? So if I'm going back to the first foundational concept, this is the words that they said, but in my own words, okay, organisms live, and I can describe how they live using physics and chemistry. There are also biological concepts that I can use, but biochemistry covers a lot of those concepts. So if I'm just trying to isolate from myself to be able to individualize what I need to review, this is more of the physics and chemistry concepts. But again, what does that mean? So even though I've broken this down into words for myself, MCAT's testing how you understand it. So you have to have a strong understanding of how everything is occurring. And each of these concepts that you learn individually, now you're going to be having to integrate, especially when it comes to macromolecules, but also when it comes to other chemical and physical principles. When it comes to foundational concept 4, they break them down into different content categories. For concept 4, there's category A, which states translational motion, forces, work, energy, equilibrium, living systems. So again, breaking this down, you got translational motion, forces, work, energy, and equilibrium. And when I think about translational motion, I'm thinking about velocity, acceleration, and position, some of the things that have to do with how quickly things move. This is how some calculus concepts have previously been tested on the MCAT. You don't have to know calculus in order to take the MCAT anymore, but having an understanding of position and velocity and acceleration, how those are derivatives of one another and or integrals of each other, may help just answer questions faster on the MCAT. So the relationships between all of those. There's also some equations that you may feel is helpful to memorize. Those equations may or may not be explicitly tested on the MCAT. Sometimes the MCAT's testing your understanding of how the equation was created in the first place, not testing your ability to apply certain numbers into equation and solve for one of the other values in that equation. I think about forces. I'm just listing different forces that I think about. So force due to gravity, force due to acceleration, force due to friction, but there's so many other forces that come into play. And so having an understanding of what those forces do, what the definition of a force is, how each of those forces has a different type of acceleration because of its mass, et cetera, is more how the MCAT is testing your understanding of forces. And this is not an exhaustive list. So work, remembering that the definition of work is force applied over a certain distance. When I say the word over, it makes me think of a division sign. And so I know work equals force times distance. So when I say in a certain distance to help me recognize that it's multiplication, not division. But there's other derived equations. It's not just force times distance. You could also say it's mass times acceleration times distance if you know force is mass times acceleration. And so being able to know how other equations can be derived to figure out what work is, as well as the units in which work exists, to be able to know what other manipulations you can do to be able to get the right units, at least to be able to say this is work, is a lot of how the MCAT is testing these equations as well. And I know there's at least one other concept where work comes into play, and that's energy, which is going to be talked about soon. But are there other concepts where it's integrated, where there are relationships, challenging yourself to be integrating these concepts as well? So then work and energy for sure is one relationship, the work energy theorem, and understanding potential energy, kinetic energy, how that relates to work, what types of kinetic energy and potential energy go into different types of work being done, if it's positive work, negative work, what all of those things even mean, not just their definitions, is very important to feel confident in your foundation for the MCAT, as well as free energy. So if we're talking about delta G, and we're talking about that equation, chemical equations, how does free energy work? And so within delta G, what other concepts are we going to have to think about? Enthalpy, entropy, as well as heat. What's the difference between enthalpy and heat? As well as overall the equilibrium. So if this is a shift, what is making the shift occur to allow for a new equilibrium to happen? If we're thinking back to homeostasis. Are there any other types of energy that you can think about? We're talking equilibrium, there's the chemical equilibrium where you have shifts in the equilibrium, but you also have an acid-base balance, and that's a different type of equilibrium than if we're talking about ionic balances. Understanding the concepts is far more helpful in making sure you have a foundational understanding when you're going to actually answer questions than just having rote memorization of the equations. But there's also physical equilibrium. So if we're thinking about a complex living organism, we're thinking about homeostasis, but there's also some other things. Anything else you can think about? Then there's content category 4B, where it says importance of fluids for circulation of blood, gas movement, gas exchange. So fluids plus circulation of blood, fluids plus gas movement, and then fluids plus gas exchange. We're thinking fluids plus circulation of blood. I'm thinking both about the blood pressure, but also about how blood flow changes impact the circulation of blood overall. And that, again, circles back to the previous concepts that we have discussed and challenging yourself to, okay, if I've separated these, how would it get integrated into other ways if I'm building myself back up from atomic to organismal function? There's also fluids, gas movement. I think about gas movement. I think for sure about the lungs and how respiration occurs. So inhaling oxygen, exhaling carbon dioxide, but also about thinking about gases overall as a concept, being fluids, and what that means as a physics concept and a chemistry concept. So challenging yourself to understand phase changes, how phases work, what makes something a gas, what makes something a fluid, what makes something a liquid, etc. And then with gas exchange, I'm thinking more even in depth about how the lung is functioning. So I'm thinking about alveolar function. I'm also thinking about kidney function. There are some gases that are exchanged in the kidneys. And so thinking about those things as well. Also thinking about gas transport within individual cells. The oxygen has to actually enter a cell for cellular respiration to occur. So how does that oxygen diffusing or in other ways being transported across the cell? Are there other ways that gas exchange is occurring? If we're talking individual cells or overall organs, organ systems, or organisms. 4C is electrochemistry and then electrical circuits and their elements. So there's electrochemistry with their elements and then electrical circuits with their elements. For electrochem with their elements, I'm thinking about the setup of electrochemistry. So I think about an electrochemical cell, both a voltaic and a galvanic cell, the differences between galvanic voltaic cells, which of those is considered an electrochemical cell, what does an electrochemical cell represent within the human body or other complex organisms, as well as thinking about ions, ion transport, how ions are created, which starts to prime me to think about an atom structure and electrons being added or removed from an atom in the first place. So we've got electrical circuits. So obviously I'm thinking about circuits, and the elements of circuits would be capacitance, resistance, current, voltage. This is not about making machines function. And a lot of times when you are presented, for example, P equals IV, power equals voltage times current, or some of the other equations that are related to electrical circuits, they're referring to making machines function. And those same concepts can apply into how the human body works, but for different reasons. So making sure you understand what capacitance would mean if we're talking about the human body. So, okay, electricity really has to do with the nervous system functioning, how nerves work. So when I'm thinking capacitance, I'm having to think both about how the charges work themselves, but this charge isn't just coming from a plug into the wall. This is coming from an ion. So how is that application going to be different if we're talking about the human body? Then 4D is talking about light and sound interacting with matter. So we've got light with matter and we've also got sound with matter. If we're talking light with matter, I think about light as a wave. And so how that wave is going to impact matter, but also light is a particle, and particle is literally is a piece of matter. So how does that affect other types of matter? What is its role as matter in and of itself? If we're thinking about complex living organisms, especially the human body, I'm thinking about light perception in the eyes. So I'm thinking about rods and cones, and I'm also thinking about how the retina is structured, how light reflects onto the retina for you to be able to see anything in the first place. Also where the lens is structured, which makes me primed to think about optics equations. So like where the focus is and all of those other associated concepts are where I would anticipate these types of things being tested. Then also sound with matter, you've got sound as waves. And we know sound is not a particle, that's a light thing. So we're just thinking about sound as in terms of waves. So if this is a transverse wave or a longitudinal wave, what does that mean in terms of how matter is going to be impacted? As well as if we're talking about complex organisms, the ears. The only reason we talk about sound really for the human body is because of sound conduction in your ears. So being able to, how you're even hearing this lecture in the first place is because of something having to do with sound conduction. So do you have at least a basic understanding of how sound traveling as a waves impacts the matter in your ear and how that relates to you being able to perceive sound? For 4E, we've got atoms, nuclear decay, electronic structure, atomic chemical behavior. This one's pretty explicit about each one of those things. So we got atoms, nuclear decay, electronic structure, atomic chemical behavior. When I'm thinking about atoms, got to define what an atom is. The current structure, the atom's structure has changed so many times over time, but what is currently accepted as the structure of an atom? So thinking about protons, neutrons, and electrons. But the MCAT is increasingly also testing your understanding of antineutrinos, positrons, muons, other things that they are finding also make up atoms, maybe not stable atoms, but more radioactive atoms. And so understanding how those are structured together to make things besides just your basic understanding of an atom. There's also an understanding of how quarks relate to making protons work, as well as neutrons. So if we're talking radioactive decay, when we're going to be talking about nuclear decay, having an understanding of that structure helps somewhat to be able to get through. So nuclear decay, if we're thinking about the nucleus of an atom, that's protons and neutrons. So the energy that allows for the protons and neutrons to decay in the first place, something's going to have to excite in order for it to be leaving, and that's how the decay occurs. So then you're also going to think about quarks and leptons. This is not an extensive tested situation, but there are more and more practice passages that I'm seeing that are testing your understanding of quarks and leptons. So just, or at least your familiarity with these things as they exist. Are there any other things that you can think about when it comes to nuclear decay? And also, why would nuclear decay be relevant into the human body? If we're thinking about radioactivity, X-rays exposure, how would that relate to potential cancers being created? Just priming yourself to think beyond just physical concepts explicitly. How would this be tested if we're talking about the human body? Why is this relevant? With electronic structure, also thinking about electrons themselves and that decay being different from the nuclear decay. So we have to understand electron orbitals as well as the energy levels within the electron orbitals, the shapes of the orbitals, how hybridization can occur within different orbitals, and how all of that also relates back to energies. So if we're talking about delocalization of electrons and other different things associated with that, we have to understand the electronic structure overall. Are there anything else that you can think about? For atomic chemical behavior, this is thinking about atoms behaving in chemical reactions. So we often think about like the moles of this and the amount of things that are in a mole. So the concept of atoms functioning in chemical reactions is circled around a lot in chemistry, but the MCAT tests it often explicitly. So do you understand, okay, this atom is actually exchanging with this other atom, and that's why this reaction is overall being able to occur. If we think about this atom structure, how likely is it for this to exchange with something else? How quickly would that reaction occur? And that's also where like organic chemistry, SN1, SN2 reactions, as well as elimination reactions, starts to get tested on the MCAT as well. Then there's foundational concept number 5. This one is 60%, so 55 to 65% of the ChemPhys section of the MCAT. And it states the principles govern chemical reactions, chemical interactions and reactions form basis for broader understanding of molecular dynamics of living systems. So even when reading that, I recognize I didn't read it appropriately. So breaking this down helps a lot more when understanding the concept as a whole. So we've got principles governing chemical interactions or reactions. We've also got molecular dynamics of living systems, and we've got foundational understanding facilitates broad application. It talks about broader understanding. So if we're talking content 5A, category 5A, it's unique nature of water and its solutions. Water in and of itself is tested on the MCAT. So what's the nature of water? When I think about water, I really am thinking about hydrogen bonding. What about the structure of water allows for hydrogen bonding to occur? What other molecules can hydrogen bonding occur with? And how does that impact the molecules functioning overall if hydrogen bonding is or is not occurring? So if we're talking about the solutions, solubility, hydrogen bonding has a lot to do with whether or not something's going to dissolve in something else. Being able to understand and anticipate how hydrogen bonding plays into solubility is a concept that is tested, but there are absolutely others. So hydrogen bonding in and of itself, thinking about bond polarity, the bond polarity letting you know whether or not hydrogen bonding is going to be occurring, but that also has to do with the atomic radius. It also has to do with the electronegativity. So if we're thinking about trends in the periodic table, this is where a lot of those concepts come into play as well. 5B, nature of molecules, intermolecular interactions. Once again, couldn't break it down. So breaking it down, the nature of molecules and then the nature of intermolecular interactions. It's the nature of molecules. So this is where I'm thinking about a molecule in and of itself. We've got ionic bonds. We've also got covalent bonds. And then in between those two, we've got polar covalent bonds. Do you understand how it's more of a spectrum than an absolute between ionic covalent, polar covalent? What makes something more likely to have polar covalent activity than ionic or covalent, pure covalent activity? We're talking intermolecular interactions. I'm thinking about hydrophobic interactions, so things that are both going to be wanting to get away from water, but also dipole moments. So when we're having polarity at some times, why are there moments where there's dipole moments occurring within atoms or within molecules? And are there other types of intermolecular interactions you can think about? Then 5C is just separation and purification methods. We've got separation methods, we've got purification methods. When I think about separation methods, I'm thinking about, okay, well, what are we separating? Why are we separating things? Separating proteins is going to help us be able to determine what their amino acid structure is, whether a protein is functional or not functional, if this protein is mutated. Also amino acids, if we're separating different amino acids, being able to understand how those amino acids may create tertiary quaternary structures based on their primary and secondary configurations. Separating DNA, trying to isolate one type of DNA from other types of DNA if you got a whole lot of DNA together. Same thing with RNA. You can also separate things based on a charge of the molecule. So if you don't know exactly what type of molecule it is, you just know that it's got a specific charge. You can separate it based on the charge. Do I understand how to separate each of these things? What techniques are used for each of these separations? You can also separate things based on polarity. And this is, again, not exhaustive. Are there other ways to separate things? What things would you want to separate? Why would you want to separate them? Think about purification. So again, why would you want to do purification? If we're trying to make sure we just have one type of molecule because you're only trying to give a patient one type of drug, you're not trying to have a whole bunch of excess other stuff. You really want to make sure something's purified. So understanding the motivation for why these things are occurring will also help you understand, like, when these questions are presented to you on the MCAT, you're not confused as to how this relates to something else. You're already thinking about that integration for yourself. So distillation is one way. You can also do column chromatography. Or are there other ways that you can do purification? Depending on what you're trying to purify, will the purification method change? And then 5D, we've got structure, function, reactivity of biologically relevant molecules. Still a whole lot of words. So separating it up, we've got biologically relevant molecules. And then we've got the structure of those molecules. We've got the function of the molecules. We've got the reactivity of those molecules. I'm thinking about biologically relevant molecules. These are where I'm thinking back to the 4 macromolecules. So amino acids, proteins, nucleic acids, lipids, and then carbohydrates. So if I'm thinking about the structure of all 4 of those macromolecules, structure of amino acids, structure of proteins, thinking about the actual organic chemistry structures. I know this section is testing far more organic chemistry. So actually, do I know what does this look like if we're thinking about the alpha configuration for these amino acids? Do I know what that alpha configuration is? Do I know what these functional groups are? Do I know how to separate the amino acids into different groups? As well as the bonds that they're making. So if we're talking about proteins, okay, what bonds form primary, what bonds form secondary, what bonds form tertiary, what bonds form quaternary, and what amino acids are able to participate in each of those bonding types. Why? And that has to go back to their functional groups being able to function. We've also got the structure of nucleic acids. So if I think about the structure of nucleic acids, again, organic chemistry. So if I'm thinking about the nucleic acids, there's the 4, 5 bases. So do I know how each of those bases is structured? What is the difference? What are the differences between DNA and RNA, especially if we're talking about their organic chemistry structures? Do I know what the sugar for RNA looks like versus the sugar for DNA? Do I know what nucleic bases are different in each of those? And what, based on the organic structure, is different to make each nucleic base occur? Then if we're combining bases together to make up strands of DNA, we have to do that via bonds. Where are phosphodiester bonds? Where are hydrogen bonds? Are there other types of bonds that are formed to make up a DNA structure or an RNA structure? Do I understand how all of those bonds are formed? Then do I understand the charge of a nucleic acid? The charge has a lot to do with how it interrelates to histones and acetylation and methylation. So do I understand the charge of amino acids? Do I understand the charge of nucleic acids and where exactly on the nucleic base or nucleic acid structure is carrying the charge? Are there any functional groups that exist on nucleic acids? When we think about functional groups, we're often thinking about the amino acid functional groups relating to polar/nonpolar, etc. But there's also like the literal functional groups that you learn in organic chemistry. So we're thinking aldehydes, ketones. Then you've got the structure of lipids. So what types of lipids? There's different types of lipids. How are each of those types of lipids structured? Especially if we're talking about lipids that exist in the human body. Lipids, as a general concept, are hydrophobic. What makes lipids hydrophobic? How do hydrophobic interactions work within lipids? And how are all lipids exclusively hydrophobic? Are there regions where there's hydrophilic regions on lipids, but they're still considered lipids? Do you understand how those things may have hydrophilic and hydrophobic regions in the overall molecules? And again, going back to just the functional groups. So we're thinking about lipids. What are the functional groups from organic chemistry that might make lipids non-polar or hydrophobic? Then structure of carbohydrates. So different types of carbohydrates. If we're thinking about glucose versus sucrose versus fructose, do you know the structures of each of those? Do you know how monosaccharides combine to make disaccharides? What is the bond that makes up disaccharides? As well as the functional groups, going back to organic chemistry. So this is really where tautomerization of keto to enol formation comes into play. Do you understand how a ring structure can be occurring from a straight glucose molecule? A lot of these other things may be tested within this section. So then we're thinking about the function of these molecules. So we've got the function of amino acids or proteins. We know that there's proteins as enzymes, but there's also proteins not as enzymes. That goes back to the foundational concepts from the biochem section. We're talking about proteins as enzymes as not as enzymes. But here, if we're applying the chemical and physical principles, what are the things that I think would be more likely to be tested in this part as opposed to the other part? Then the function of nucleic acids. So if we're thinking about transcription, if we're thinking about the physical concepts, so chemistry and physics, how is transcription and translation occurring? If we're talking about the rate of chemical reactions, each of the bonds that's making a DNA molecule longer is a chemical reaction, which is facilitated by an enzyme. Do I actually understand that as a physical concept for both transcription and translation? as well as just storing genetic material. So if we've got DNA just chilling in the nucleus of a cell and it's bound to histones, do you understand how DNA can bind to histones to be able to not be accessed, and how histone binding and unbinding works? We've also got functional lipids. So we're thinking membrane structure, but they're also involved in storage and signals/cofactors. Do I understand what lipids might relate to hormones being created? What lipids might be involved in storage within the cell? Why lipids would be really helpful to store things in a cell, as well as membrane structures, both the cell membrane, but also are there cell organelles that have membranes, and what do those membranes look like? And then the function of carbohydrates. So we've got energy storage, that's also a source of energy. And how are those things related to physical principles? Then we've got the reactivity of those molecules. So amino acids and proteins, their reactions, a lot of that is the bondings that occur in the primary, secondary, tertiary, quaternary structures. They've also got the denaturing. So if we're building up a protein, you can also break it down. What bonds are broken if we're denaturing a protein from quaternary to tertiary, tertiary to secondary, secondary to primary? What things are you breaking apart in each of those denaturing processes? Where are disulfide bridges occurring? Why are disulfide bridges occurring? If we're thinking about special amino acids, do you know the amino acids that are involved in disulfide bridges and when those disulfide bridges are helpful within the cell? We're thinking about nucleic acid reactivity, interaction with histones. So going back to storing DNA material, we're thinking about the methylation as well as the acetylation of histones. We're thinking about lipid reactivity. Saponification is one reaction that may be tested when talking about reactivity of a lipid, but also lipids as an energy source. If we know, okay, cellular respiration is most often talking about glucose, but there are other molecules that can insert themselves into the pathway and also serve as an energy source because they can be broken down to create ATP at the end as well. So do you understand how that lipids can be used as an energy source? And then carbohydrates. We know about cellular respiration with carbohydrates, but do you know about the keto-enol tautomerization, as well as functional group reactions? So if we're talking about an alcohol becoming a ketone, or if we're talking about other functional groups changing amongst themselves, if we're talking carboxylic acids changing into something else, challenging yourself to think about all of the functional groups that may be involved with carbohydrates and how are those functional groups going to have reactions, especially in the human body. So some of those reactions are going to be substitution versus elimination. Do you understand when you would have substitution versus when you would have elimination reactions occur? Why a molecule would be more likely to do one versus the other? And then for 5E, lastly, the principles of chemical thermodynamics and kinetics. So this is really all about enzymes. How do enzymes function? So we talked about delta G previously, but delta G comes up even more in this part. We're talking about enzymes, but also rates of chemical reactions. The MCAT does not test the foundational concepts explicitly. It breaks them up into 4 different scientific ways. The MCAT doesn't test the foundational concepts explicitly. It tests them in 4 different ways, known as scientific inquiry and reasoning skills. And there's 4 SIRs. There's another video that will break down the SIRs for each section more in detail, but the SIRs are overall how the questions can be presented. And each MCAT section is going to have a different focus for SIRs being tested. For example, the ChemPhys section may test your ability to assess a experiment, but it can also test if you understand how to read data and chart analysis. Those 2 things can be tested for the same concept.